Hi guys, we are back with Gas 101, and these are notes for my Chem 100 class. This is part 2, and we're talking about the gas laws here. And the homework are going to be 3 worksheets, gas 1, which will go pretty quick, and then gas 2 and 3, which you might have to take a little bit more time with. There are 3 gas laws I'm going to talk about here, and those include Boyles Law, Charles Law, and Gay-Ludacri's Law. I wrote this out over here because this does not look like it says Gay-Ludacri's, but that's how you say it apparently. And if I'm butchering that, I apologize to anybody out there. Okay, so Boyle's Law says that the product of pressure times volume of a sample of gas is a constant number. And we want to remember for Boyle's Law, for all of these laws, there's going to be a constant. So here, pressure and volume would be changing. And we want to remember what we're talking about with Boyle's Law is that it's at a constant temperature. So with Boyle's Law, temperature is unchanged. So the way that that works is if we take an initial pressure, which is indicated with P1, and multiply it times an initial volume, and then somehow the system changes to a new pressure, and then there will be a new volume. So let me just really quickly define these. This would be initial pressure, and V is initial volume. P would be pressure after the change, whatever change it is. And V2 would be volume after change. Okay, and so you can see it's a 4-variable system, and you'd always be given 3 of those 4 variables and be asked to solve for the 4th one. Okay, so one thing that you want to remember is that pressure can be in any units for these. They just need to be the same on both sides. So if you have like kilopascals for an initial pressure and you're given in atmospheres for the second pressure, and then you'll need to convert, and we'll talk more about that here in a minute. So pressure, any unit's okay, just need to be the same both sides. And volume is the same way. So you can use any units for volume, milliliters, liters, cubic feet, cubic centimeters. It just needs to be the same on both sides. Okay, so this is Boyle's Law. P1 times V1 equals P2 times V2. And like I said, we'll do some calculation examples in our part 3. Okay, so Charles' Law is going to be this in green just to be consistent. We'll say the ratio of volume compared to temperature is a constant number. For any gas sample. And in this case, we would want to remember that we're going to have a constant pressure here. URE. Sorry, it's kind of late when I'm lecturing. Okay, so the way that would manifest in a mathematical equation would look like this, that you would have initial volume over initial temperature is equal to secondary volume over secondary temperature. And once again, volume is any units, okay? They just need to be the same on both sides. And then you always want to remember temperature always has to be in Kelvin. And so you want to remember to make that change before you do any calculations. Again, this is a 4-variable system. You'll have 3 of the 4 variables given, and then you'll just have to do a little bit of baby algebra to find the 4th one. Okay, so that's Boyles Law, Charles Law, and then Gay-Lussac is really similar looking to Charles Law, but instead it is about pressure and temperature. So we're going to go here and say the ratio of pressure to temperature is a constant number. And we want to remember that in this case, we would have a constant volume. So if the volume's not changing, then the pressure compared to the temperature is a constant number. And what did I use? I used black, so I'll use black again here. So we could have our initial pressure over our initial temperature is equal to a secondary pressure over a secondary temperature. Okay, so pressure in any units is okay. They just need to be the same both sides. No apostrophe there. And then temperature always has to be in Kelvin. So take your degrees Celsius, add 273, and that's equal to Kelvin. Okay, so that's baby algebra to solve for the 4th variable, whichever one you're not given. And then I am going to actually go into one more law, and that is the equation baby of all 3 of these. If equations could have children, the combined gas law would be one of them. Would be the baby of all 3 of these. So the combined gas law takes all 3 of these and puts it into one big gas law. It looks like this. Pressure, initial pressure times initial volume over initial temperature, P1 V1 over T1, is equal to P2 V2 over T2. So you can see it keeps the pressure and volume on the top, and then the temperature, it goes on the bottom. And the same rules go for pressure and volume, any units okay. Just need to be the same on both sides. And with temperature, get it into Kelvin. Okay, those are the gas laws: Boyles Law, Charles' Law, Gay-Lussac, and the combined gas law. Okay, and we'll come back with part 3 here momentarily, and we'll do an example calculation for each law, as well as a couple of temperature conversions, or not temperature, pressure conversions. Okay, thanks, bye.